Dear colleagues, from the point of departure session, we will give still 2 minutes before we start so that we allow people to come into the session. Thank you. My name is Elva Escobar. I'm an autonomous university in Mexico, and I study the deep sea tropical seafloor in Mexico's regional seas. It is a great pleasure for me to introduce Dr. Tanya Stratman today. Dr. Stratman is a deep sea benthic ecologist with a PhD in marine sciences from Ghent University in Belgium, in cooperation with the NIOS, the Royal Netherlands Institute of Sea Research in the Netherlands. During Dr. Stratman's PhD and current postdoc at Utrecht University in the Netherlands, and as guest researcher at the Max Planck Institute for Marine Microbiology in Germany, she has been studying the environmental impacts of deep sea mining and of polymetallic nodule extraction. Dr. Stratman has been involved in several European deep seabed mining projects over the last 7 years, such as MIDAS and the GPI Ocean projects Mining Impact 1 and 2. She has participated in 3 deep seabed mining related research cruises to the Peru Basin and to the Clarion-Clipperton Fracture Zone of the pre-prototype collector vehicle Petania 2. Dr. Stratman will introduce us to the theme with a 15-minute presentation, after which we will open the floor for question and answers session, and after which we will initiate a discussion forum to hear of innovative solutions from the audience and how to walk to return to a clean ocean while using more resources from the ocean. Dr. Stratman, you have the floor.
Thank you, Elva. I see whether I managed to share my screen. I hope that you all see my screen now. Today,
we can see your screen. Thank you.
Yes, Perfect. Today, I want to take you on a dive to the deep sea below 200 meters of water depth, which is the largest ecosystem on our planet. If you have a look on this map, everything that is blue here is actually deep sea below 200 meters of water depth. And as you can see, more than 60% of the surface of our planet Earth is deep sea. And a lot of this deep sea is covered by this soft sediment that you see in the picture. The soft sediment is very fluffy and can easily be resuspended by human activities, like you will see in this video. We have an ROV here that uses its arm to collect plastic trash, but meanwhile it also disturbs the sediment a little bit. There are particular deep sea areas like the Bermuda Rise where deep sea eddies, which are type of or similar to hurricanes on land, that are strong enough actually to resuspend the sediment at the sea floor. These are very, very localized events, and in the deep sea area of the Clarion-Clipperton Fracture Zone, which is south of Hawaii and west of Mexico, that is the area where deep sea will most likely happen in the future. Eddies are actually not strong enough to create the sediment plume that you see here. Also, on these images that were taken just a couple of seconds after each other, you see how a sediment plume develops and might even disappear again. So the organisms that live at 4,000 meter depth are actually adapted to very clear waters with very low particle concentrations. And in the Pacific seafloor, south of Hawaii and the west of Mexico, the sedimentation rates are actually so low that only a couple of millimeters of new sediment reaches the seafloor within 1,000 years. Which means that the organisms are really adapted to this very low particle concentrations, and they are even so low that the organisms are able to, no, let's see whether this works. Otherwise, I switch to the actual video. Okay, let's otherwise do it like this. You will see now a sponge here. This video is a time-lapse video taken by colleagues at MBARI, the Monterey Bay Research Institute, and they filmed the sponge that frees itself from sediment particles in this absolutely clear seawater at about 4,000 meter depth. So imagine now you have this situation and this behavior of the sponge under clear ocean. Sorry. This ecosystem is quite stable. However, it's really threatened by mining that induces deep sea sediment plumes. What is deep seabed mining? Deep seabed mining is actually defined as the retrieval of mineral deposits from the sea below 200 meters of water depth. And one of these mineral deposits are polymetallic nodules that you see in these pictures. They occur between 3,500 and 5,500 approximately meters of water depth, and they're considered potential future resources for metals such as cobalt, nickel, copper, but also iron. And I will use this cartoon now, published last year by Jeff Drazen and colleagues, to explain you how deep seabed mining will create these sediment plumes in the deep sea. So you have to imagine you have a deep sea mining vehicle, and this might look like this one. This is a pre-prototype called Tanya 2, and you will have contact with it later on again. This pre-prototype or this mining vehicle will move along the seafloor and collect the nodules, and meanwhile create the so-called collector plume close to the seafloor. The nodules will then be raised to the surface where we have the support vessel via a vertical transport system. And at the support vessel, at the sea surface, these nodules will be dewatered, and a mixture of sediment and water the so-called dewatering plume will be discharged again below the sunlit zone, below 1,000 meters of water depth. This collector plume at the sea floor will eventually settle at the sea floor and blanket it and potentially also smother sensitive fauna and organisms. And 2 years ago, colleagues of mine performed a small-scale dredge experiment in the Clariton-Clipperton fracture zone, where they measured how much sediment was redeposited at different distances to this dredging area. So this was very small, and directly at the dredging tracks, they found 9 millimeters of sediment that was redeposited. When they went 320 meters away from the tracks, the sediment redeposition was still 0.07 millimeters. And when they calculated the area that was affected by 0.5 millimeters of sediment, which is a sediment thickness which has already negative impacts on fauna, they found that this area had the size of approximately 6 soccer fields. So just this tiny dredge experiment had already an effect on 6 soccer fields of sediment flow. They also measured how far into the water column this plume would spread, and they measured it up to 20 meters above the sea floor, which is interesting because in the bottom waters, colleagues of Oliver Kersent himself found that there are a lot of meioplankton larvae that really spread here and live in this bottom water. So the sediment plume of the collector plume will have effects on the dispersal and recruitment abilities of abyssal benthos, so organisms living in and on the sediment surface. That could be, for example, lead to slower rates and changes in the patterns of benthic community recovery after a mining operation has ceased. This year, I had the chance to join within an EU project, Mining Impact 2, monitoring cruise where we independently monitored the test of Tanya 2, this vehicle that I showed you a couple of slides ago. This was the pre-prototype collector test, and we want to study the plume dispersal and the effect on the benthos. So we went there with 2 ships. We were on one, Tanya was deployed from another ship, and we took pictures of the sea floor. This is the sea floor before the start of this mining experiment. So you have all these nice nodules here, half buried in the sediment like they would normally occur. And after the sediment plume has settled, the area looked like this. This is approximately the same site. It's not the area that was actually mined because there all the nodules were gone, but it's an area that was impacted by the sediment plume. And you see that all these nodules are covered. They're all these tiny bumps on the picture. And my colleagues actually determined at the moment how much sediment was resettled and how thick this resettlement is. Not only the benthos is affected by the collector plume, but we will also have the dewatering plume that affects benthos and midwater organisms. So we are here now at the plume that consists of the sediment and water after dewatering of manganese nodules that will be discharged again either below 1,000 meters or further towards the sea floor. And we will expect, depending on which type of scenario will occur, because deep seabed mining hasn't started yet, about 5 kilograms of sediment will be discharged per second and 3 kilos of nodule fines per second. If you think about a 20-year operation, this means that 120 million kilograms of sediment will be discharged from this one operation, and that is equivalent to the weight of about 80,000 VW Golfs. Additionally, about 61 million kilograms of nodule fines will be discharged, which is about 41,000 VW Golfs. And when you have a look at which area the sediments will redeposit, it will be an area of about 1 million or more than 1 million square kilometers, which is approximately the size of Europe, or Europe is a little bit larger than that. So the area and the impact by just a single mining operation over its lifetime will be huge. And it would not only affect the benthos, but also the mid-water column organisms, like you see here in the picture. They will be affected by different reasons. For example, their respiratory and olfactory organs will be clogged, as well as some of these organisms form mucus filter nets to catch small particles they feed on, and they will also be clogged. Furthermore, suspension feeders will encounter dilution of their food source, because a lot of the particles they will start to filter and to take up are actually inorganic sediment particles that are not very nutritious for them. When organisms like the Gilantinia zooplankton get in contact with these sediment particles and they start to stick on their organisms, they will encounter very likely reduced buoyancy and have problems keeping their level in the water column and continue to swim. There will also be reduced communication bioluminescent signaling, because the sediment plume will absorb the light, which is a problem, for example, for a lot of predators that use light to attract the bait. And even we humans might be impacted, because the sediment plume could also contain metal contaminations, for example, copper, that is then absorbed by migratory zooplankton, which forms the of commercial interest, like, for example, tuna. So there's also an interference of high seas fisheries, like tuna fisheries and seabed mining. Hence, our aim should really be to reduce the spread of mining-induced sediment plumes as much as possible.
Thank you so much, Tanya. We have learned a lot about the plumes and how these plumes, if mining would take place, could have an effect on ocean water quality, on its physical properties, and mostly on life in the deep sea. So now let me guide the audience how this breakout room works. And I'll ask you to go to your screen, and you will find a raise hand icon that you can use so that we can give you the floor. You can also send your questions in written form on the chat, and I can read them for you, and either Tanya or myself can go ahead and answer the questions. The floor is open now for questions for the audience. I hope that after finishing a question and answer session, we can initiate a discussion forum to hear of innovative solutions from all of you and how to walk to return to the clean ocean while using more resources from the deep ocean. Thank you. So we have a couple of hands that are already raised, and allow me to provide them to people. We have Janet Everett. Janet, please, you have the floor to ask the question. To Francisca. Francisca, would you like to speak? Would you like to pose your question?
No, but thank you. I didn't have a question.
Any questions? Any more? Jane, would you like to try to speak? If you have any question? Yes, Jane, please, go ahead. Your microphone is open, Jane, if you would like to speak.
You could otherwise also write your question in the chat.
That is correct, Tanya. So tell me, Tanya, what are among the questions that come to my mind is how long will the sediment remain in the water column or deployed? Will there be a way that we can say it will clean itself, and what the times will be there in the deep ocean?
Yes, so you do have different particle questions. Particle sizes. So the larger fraction will resettle quite fast, while the smaller particles could really stay in the water column for like years to decades. And this is probably these are probably also the particles that then will start clogging organisms and so on. Wait a moment.
I remember having read that the times of recovery of the deep ocean processes goes over hundreds to thousands of years. How much do we know about that?
So about the water column processes, even less than about sediment processes. For sediment processes, there was a study conducted in 1989 where a group of German researchers went to the Peru Basin and conducted a small-scale experiment where they disturbed the sediment, and we went there again in 2015 to see after 26 years how much of the benthic ecosystem had recovered. And at that moment, we still saw a reduced amount of benthic biomass, but also I developed some food web models, also reduced fluxes and like biogeochemical fluxes, nutrient fluxes, but also carbon fluxes.
Thank you, Tanya. Jane, your hand is still raised. I wonder if you would like now to take the floor and ask your question. Oh, okay, you closed your microphone again. So, what are the ideas? What ideas can we have for having a cleaner ocean by 2030 or starting to clean it up? Do we have options for the groups that are the contractors and that plan to mine? Do we have any suggestions, any opportunities that they can work with scientists, that they can work with different groups in order to reduce the impact?
Yeah, so for the sediment plumes, there are different ideas. So especially for the dewatering plumes, one option is to go quite high up in the water column. So I think even the International Seabed Authority says that this water dewatering plume should be below 1,000 meters, so below the photic zone where primary production occurs. If we spread it there, it will spread way further, but it will be diluted. And the other idea is to really pump it more or less to the seabed and discharge it directly at the seafloor that is anyway destroyed, so at the spot where the mining occurred beforehand. These are different options. And then there are these eddies that I briefly mentioned. So these are like, they occur actually, or they develop from hurricanes and storms that pass over Mexico, and then they turn into spirals in the water, and that leads to increased current at the seafloor. And one idea could also be to use these eddies and discharge the water more or less during the eddy formation when the water currents are stronger, so that the water, the dissolution of the particles will be faster and more widespread. So these are three different ideas that exist at the moment.
We have a comment here from George Cummings. George, would you like to present your comment directly? Or I can read it for you as well.
Oh, it's just that this is such an emotional. Thank you, Elva. Can you hear me?
Yes, of course, we can hear you.
Good. Okay. So this is really, really emotional, and for me, it began back in 2017 when they gave all of us at the Ocean Conference Greg Stone's book, The Soul of the Sea. Greg Stone, for those who don't know, was the author of the Ocean Health Index. You know, the 127 factors. So somebody who's extremely passionate about the ocean, and over time, Greg has gotten very involved in this deep sea mining. I'm going to just call it trade-offs. And so it's really, for me, it's just become so complex. You know, on one side, we're trying to find the minerals to make renewable stuff and not be something that's, you know, some child in Africa who's basically giving us a life so we can have, giving their life up so we can have lithium for a battery. You know, I mean, it's just, it's mind-boggling, the complexity of this. And it's the emotional trade-offs of this. And obviously we don't, as Tanya's pointed out numerous times, we really don't know very much about this. So we just have, we have to allow some kinds of experiment that's as controlled as possible till we figure this out, and try to get us, in essence, we've got to get off of fossil fuel. We've got to get to something else. We all know that. And at the same time, we don't want to destroy the life support system of our deep sea ocean. So it's just, I don't know. I know I don't have the answers, but I know I'm more emotionally confused now than ever, almost, that, you know, what do we do? What do we allow? It's just, it's very hard. So I look forward to hearing all the ideas that are going to come forward, and I'll just be quiet.
Thank you, George. Jean, I see that you have your microphone on. Would you like to take the floor? Would you like to comment something?
Can you hear me? Can you hear me?
Yes, we can hear you, Jean.
Oh, wonderful. Okay. I think I think you've partly already addressed the question. One was whether there was a way to mine without creating plumes. And then the other was is there chemical treatment happening on those boats that are harvesting the plumes, that there's then spillage of particular chemicals other than the plumes that come from the seabed floor itself? Those were the two questions.
Shall I take the questions?
Yeah, please go ahead.
So there is no way not to create a plume. For example, just this collector, when it starts to collect the nodules, and for example, the system that Tanya 2 used, the prototype collector, that more or less uses jets to flush out the nodules, and there's no way not to create a plume. I think it's we should make sure that the creation of the plume is minimized to the maximum, but there's no way to not having a plume. And regarding any chemicals on the vessel, I think there is so far no idea to process it on board. So the idea is so far to ship the nodules to shore. However, the nodules contain copper, for example, and copper itself is toxic to organisms. And when they start grinding up these nodules maybe on board already, and part of this copper will then probably also be released within the mining, this discharge plume with the sediment. So they are very likely chemicals released, like metals that at the moment concentrated in these nodules. But as far as I am aware, they don't plan to actually use chemicals on board. That would also be problematic because of all the agreements for not spilling pollutions in the sea.
Great. Thank you so much.
Thank you. So among the different trade-offs that we have to deal with while trying to move into a cleaner energy source, this would be a way of not really getting very clean. Would it be, Tanya?
Yeah, exactly. I mean, one argument is always we don't want to have child labor in Congo, but I don't think by you destroying another ecosystem, we solve child labor in Congo. I think if we want to solve these issues, we have to go to Congo and solve the problems there. So we're trading two different ecosystems, and destroying the deep sea will also have consequences for human kind. It's not that by doing deep sea mining, we save something else.
Exactly. Exactly. From the audience, I would like to promote a little bit of interaction. And I would ask you, do you foresee any potential solutions of moving into going back to a cleaner ocean? Because we talk about clean ocean, it's actually that we're looking to the past. We are looking to those times in which our ocean probably was not so much altered. It did not receive so many pollutants from the activities. As I recently heard in a presentation, we are standing in only 10% of this planet, but our impact is very large. It is 71% of the area is ocean and 29% is the continents, and we only use 10% of those continents because there are areas in which we don't live, like in the center of deserts because there is no water, or in the middle of the Antarctica. But in this 10%, we're actually doing a lot of damage to our oceans with pollutants. So to the audience, this is a question addressed to the audience in trying to pursue for innovative solutions. How can we move to have a cleaner ocean in spite of requiring minerals probably from the ocean or using other resources from the ocean? Any idea, any comments? How about promoting science? How about promoting that we produce other materials to generate energy, cleaner energy? George, you have the floor. I think your microphone is on.
Yes. Well, you know, I'm not bashful. I'll speak up. Yeah, I think it really comes down to a lot of us as individuals really radically changing our consumption habits. Until we do that, because in essence, we keep getting in developed countries, we keep consuming things that ultimately we really didn't need, but some marketing entity or some way we end up getting them. Then they end up in a landfill. Maybe they get used once more that they're donated somewhere, but in reality, we just have all this stuff that we just keep creating. So part of it is us as individuals, and the other piece is industry beginning to literally recreate itself to make products that have a much longer life, have second, third, fourth lives, and in essence, we go to however we get to zero waste, meaning we recycle and use everything. That just feels to me as that's something we as an individual can do. We can control our habits. We can't control what our politicians do, and we certainly can't control what a bad actor that runs the government in the Congo allows to do either. Very, very difficult as an individual action. So that's just the gut feeling of me. We have a global citizen responsibility to our planet and our fellow citizens to stop consuming. Just really, really think, do I need that thing or not? I'll be quiet.
If we can also communicate it in a very simple form to teachers, to schools, to younger students that will be our future. So I really foresee a great hope. It's not all negative. I see that we have solutions for many things. And as I said, I mean, promoting more science, that we have more data is very important. It's important because I can see that it is very difficult to anticipate how best to mitigate potential impacts of the deep sea mining, because there have been so few studies that are investigating mining impacts and that can resemble those actually caused by mining activity. And those, I think there are none that have been done on the scale on which deep seabed mining will take place, like the size and the years that it will take place. So maybe modeling could be another great tool that we can start developing. I don't know, Tanya, what do you say about that?
Yeah, I mean, the biggest test so far was the study earlier this year that I mentioned, the Tanya trial, but that had went on for 48 hours, I believe, in one area. I mean, this is nothing compared to what we expect will happen during an industrial scale. And already there we saw that it's also very difficult to predict. So in order to set out the monitoring area that we needed to actually measure something, we didn't, of course, have sufficient monitoring instruments to place it all around. So we had to use a model developed by a very nice colleague that gave us probabilities where the plume would end, very likely. And in one of the two areas, so we went to the German license area and to the Belgian license area, and in the Belgian license area, we had really good luck that the ocean, the deep sea currents behaved like we expected them to behave. So we were very able to measure the sediment plume. But in the German area, the topography was a little bit different, and we didn't have that strong currents as we expected them to be. So we had more like a circle instead of really back and forth current. And that led us to really partly miss the plume. So it's also really tricky actually to measure it. And I mean, we are far away of any industrial sized mining experiments.
Exactly. And some people are talking about probably mitigating the effects. I think some ideas come out that we could mitigate that effect, negative effect on the fauna, on the seafloor, on the water. But then we have to probably review what the mitigation applies in shallow water extractive activities. But I think this is not applicable in the deep ocean and should be reviewed once again. We can see some challenges that are really associated with the restoration and the recovery in the deep sea bed. We can speak about, for instance, the slow recruitment, the slow growth of deep sea species, and in particular, the potential vast scale of the mining impact and the limited understanding of the requirements for proper ecosystem function. So in your point of view, do you think there is a possibility of restoring or recovery, even these small areas that have been impacted?
Yeah, a colleague of mine, Sabine Gollner, actually developed an experiment where she had sediments from the deep sea collected and made artificial clay nodules that she placed on small frames at the sea floor. And over the next 30 years, she plans to recollect them after a couple of years each time to analyze whether there's any potential recovery. And I think she collected the first one after half a year, and she found one polychaete, so one worm or so. But this is a tiny dimension. And also, if we want to, for example, restore these hard substrates, I mean, one option is to dump it overboard, but then it will likely sink into the sea floor. And at the moment, it's really at the sediment surface. So then you would have to put it manually, more or less, with an RV, which is economically not feasible. I mean, I'm just imagining like an army of mini RVs deploying artificial nodules. So I think this is also not really the idea to go forward.
Yeah, it's the number of tests have been very small, as you mentioned, and even if benthic remediation was feasible, technically feasible, then the financial commitment required would be very extensive, and we should probably consider what is more costly: the cost of extracting the minerals and what we will obtain from those minerals, or the cost of restoring, and if we can really restore, that would be the difficulty. Even transplanting larvae or seedlings of larvae and artificially eutrophicating the system, so that it would be just cost amounts of money that it's just impossible to think. Some people are talking also of offsetting as a last stage in the mitigation hierarchy, and that would be to protect similar type or equivalent amount of habitat under threat from existing plant activities. For instance, preventing trawling.
I think we lost Elva. I wasn't sure the first time whether it was my internet connection or Elva's.
Yes, she is gone.
Jean-Marc, do you want to say something while we're waiting for Elva to return to us?
I'm here.
I will.
Ah, she's back.
Oh,
I don't know what happened. I was just suddenly kicked out of the session. But okay, go ahead, please, Tanya. You're leading now.
No, I'm not leading. I actually gave the floor to Jean-Marc.
Oops. Let me just try this again there. I think that will work. I might as well come on camera. I was silent mostly for the reason that George mentioned. It's very emotional for me too. After more than 40 years working in benthic sea bottom communities and deep water communities mostly, I'm just puzzled by humans and this idea of extracting sediment and extracting nodules and destroying what lives there. I work for the Canadian Museum of Nature, and I think one of the aspects that I try to do is educate the public, and particularly the very young one, when we talk about the organisms that live at these depths and in the sediment, fine sediments. Often you don't see them, as you illustrated with your sediment there. You don't see what's there, but it's full of polychaetes and other groups. And I think most of the people that are planning to change their TV set or their iPhone for the latest version have no idea what a polychaete is and what it means for the whole ecosystem and for us ultimately. So I think a lot of it is about education, and we might be able to reach the young faster than and I'm a researcher, so then saying we need to do more research, because while we need that, I think the industry very much set into overexploitation. They don't care. It's the dollar sign at the end. There's echo there. So someone has a microphone on. Okay. So the industry is not going to change that quickly. Science is going to take time. So I think reaching out to our youngest population and telling them why it's so important not to do that is the best thing. It's still not going to be fast enough. I don't understand why we're doing that. but emotional, just like George said. Oops, sorry. I'm done.
Thank you so much, Jean-Marc. I think your comment is really relevant. And education is probably one of our most important targets that we should foresee as immediate opportunities for action. Try to educate, try to inform people, and probably take also actions that can stop or at least delay the possibility of starting mining, so that we understand much better how the ocean works. We have to shape a new ocean narrative and identify much more opportunities that the different stakeholders, that ourselves, the right holders, like our children, have for the future. So we have to listen to all these different voices at some point.
We have another raised hand by John. Do you want to?
Yes, if it can. Yes. Can you hear me this time?
Yeah.
Yes, we
Great.
can.
This is really, recently I was told, I wrote my question in the chat. I was told recently by marine environmentalists, we were debating about deep sea mining, and he played devil's advocate by saying, well, actually, it really is pretty much a desert down there. And he was a scientist, I wasn't. And I was like, no, how can you say that? And I wanted to know what would be your quick argument back if somebody says that, relative to coastal marine environments, there's not really that much down there. And I know we still have to research, and that's his argument, not mine, of course. But what would be your fire back argument when you hear somebody says that?
I think personally that marine biodiversity in the deep sea, and especially at abyssal plains, is way larger than in coastal marine areas.
I'd probably add that this is another fraction of the lack of knowledge, and we have to try to educate more people about that. There is a confusion between abundance and diversity. And diversity, I would say, the richness of the different taxa that we will find in the seafloor and in the water column. Water column has been, the study of the water column is starting just right away. And I think it is important that we know that the diversity that we have in environments such as the deep sea floor is so large that every single sample will have different components, taxonomic components, from the next different sample that we take. And the sum of all these different samples invites us to understand this richness in this vast ecosystem with a lot of rare species that are so important probably in their function, very precise function in this sea-water interface. Jean-Marc, I'll give you the hand. Please, go ahead.
It's an excellent question and a good point, because it is nearly invisible. And that's something that I try to show our students, our young people, because I've been fortunate to do some mesocosm with soft benthic, deep water soft benthic experiments, and filming tiny little polychaetes and their feeding and different activities in the sediment, so I can use that material. But I think there's also the aspect of proximity. While there's a great span of soft sediment and not so visible rich fauna, it is there, but not so visible. There are other more harder substrate habitats, and we're finding more and more of these coral mounds that are basically the results of we often call them Lophilia mounds in deep water. We're just discovering that this little bump on the seafloor was more than just a bump. It was created by that, and plenty of association with these skeletal mounds. And so I always refer people to the NOAA dives, one expedition just completed now, and there's plenty of other dives organized around the world. And I invite people to go see what's going on there, because the richness, the images live that comes out of that is just incredible. So again, pointing to the right sources of information is essential.
Thank you. Thank you both. That was great.
Thank you, Jean-Marc. It is very important what you just mentioned. Alison, you have the floor. Is there any comment, Alison, that you would like to tell us? Well, in the meantime, I would like to just mention that I always insist in strengthening research. And in that way, we can also strengthen research in development and demonstration programs to scale up, for instance, the needs of these offshore wind or the different ways of using all other means of energy. I also consider that strengthening research and development for other ocean-based renewable energy technologies will be useful. So it's not only in strengthening the research for the deep sea biodiversity, but also on other different fields that can help us stop for a while, think about if we really need deep sea mining, but strengthen the research in all the different fields, including the development of economic incentives to favor less mineral intensive global energy systems, for instance. I don't know, the research community is so large and so diverse, as is the diversity in the deep sea floor. And I think that's the reason why I always think, let's generate new knowledge. Let's invest in knowledge and let us know how we can move forward. Maybe in the future, we will not need to extract minerals from the deep sea floor. What do you think? I'll ask the audience. Maybe I can promote a little bit of discussion about that.
I do have one comment. When do we have to leave the breakout room?
Oh, we still have 6 minutes.
Okay, perfect.
Of discussion. So we are still in time. We were given 45 minutes after your presentation. So we still have time.
George, do you want to speak up?
Sure. To answer Elvis' thing, I have been hearing mostly from Elon's camp. You know, here in Austin, Texas, that's Elon's new headquarters, so we're constantly bombarded with his messaging. There really is supposedly some point out there where we'll have, because the recyclables are going to be in the 80-90% for this renewable stuff, some of these renewable storage things. Plus, there's so many, like Elba has pointed out, there's so many alternatives that we're learning about. You know, we just don't have them deployed and scaled yet to see if they're going to have enough impact to move the needle. But there's so much hope in the technology and the alternatives and all that coming now. And if there is actually, maybe it's 20 years, but at some point in time, we won't need to mine anything anymore when we move into this world of, I just call it energy utopia. When we get there, that we won't have to mine anything anymore, or anything near what we're going to have to mine, because we'll have a looping system like I described earlier, that everything we're doing just kind of swirls around has an old life and a new life, and really never goes to the grave. So I'm encouraged. I'm trying to keep hope alive that humanity is very clever, and we're going to use technology and behavior change to get us out of this. And I'll be quiet.
Yeah, that is correct, George. I fully agree with that. And I think what we have seen is that there is a significant environmental and social impact of the mining on land that could be improved, in particular with a focused effort. But if we consider that that impact goes down to the ocean, where we have this fluidity of the water, this connectivity, then we really get scared. And I think for that reason is that we should look how to promote circular economies, for instance. That could be a possibility. Create incentives to remove these barriers to implementing the circular economy, or simply look not to the oceans as a source for the minerals. See it in a different way. See that our ocean promotes our well-being, that in the planet, a clean ocean will allow us to have all the services that we need, in particular, oxygen, 2/3, food for the future generations, and the future of water for the planet. So those would be the way I would probably think about trying to explore for the future how we should use more the oceans as providers of those services that allow us to keep us alive. We have here a comment from Alison.
Eva?
Yes.
I don't want to interrupt you, but I have the feeling that we are actually supposed to return, because I think Monica is moderating again something.
And listen to the interactive lectures. Thank you so much. To all of you, thank you so much for your participation, and see you at the core event. Thank you so much.
Wales and Prussia.